Welcome to the February session of Dr. Spotfire. My name is Neil Kanungo and I'm your host. Welcome to our live stream. You can feel free to leave your questions in the chat and we will bring them on the screen like this. We're going to be doing a live stream during this entire session. So, you feel free to jump in, jump out. We had a great session today. We're going to be talking about the OSIsoft PI connector. Let me go through my little intro slides here for a second. All right. So first off, our Dr. Spotfire motto is learning is driven by questions, not by answers, or not driven by answers, but by questions. So the questions we ask is what drives us to solve analytics problems, and asking questions at the right level, not too broad, not too specific, gives us the most robust analytics, and that's what really drives our learning. So be sure to subscribe to our YouTube for our recorded sessions. This session is being streamed right on YouTube right now. You might be seeing this on YouTube, on LinkedIn, on Twitter, or on Facebook, but all the sessions for posterity will be on YouTube. Our next session is on database writeback. We'll have our Dr. Spotfire team member, Jose Levigari, on the call, and he'll be leading this session on database writeback. That's going to be on March 1st. We're also going to have Athir Alatar on the call as well, covering some topics on database writeback. Now, it's a really popular topic. We hear requests for this all the time. So we're going to be going over different ways to do database writeback, as well as community examples and scripts that you can use. So be sure to join that session. Now, today we're going to be joined by Athir Alatar, and he is also our Dr. Data Science. He has just recently become our Dr. Data Science. So he's got a session that's on the third Wednesday of each month at 9 a.m. Pacific, right at this time slot, but on the third Wednesday of each month. So be sure to subscribe to the TIPCO Data Science channel, and you can get Athir sessions. He just did a great session on how to handle missing data. And Athir has a strong Spotfire background, so he's going to be using just a lot of general analytics and general data science in his presentations, coming from someone that is a Spotfire user just like yourself. And today's session is going to be using the OSIsoft PI connector, and I'm joined by Athir Alatar. So let me go ahead and welcome Athir to the screen. Athir, how are you doing this morning?
Hi, Neil. Thank you for having me today.
Yeah, thanks for joining. This is a really important topic. We have OSI PI is a data historian. It's a really strong suit of Spotfire to be able to use this PI data, I think, in analytical applications. And when I say analytical, I mean also to use analytic data, not just transactional data, to use measurement data, numerical data over a long period of time, deep historian data. I won't go too much into that. I'll let you talk about it since you're the expert on it. But I'm glad to have you on the call.
And then, yeah, thanks for the introduction, Neil. OSI PI is a very important historian, and then you can almost find it like everywhere, especially like in oil and gas. It's very popular over there, and coming from midstream industry, we use it, and especially we use that connector in Spotfire very extensively. And it's also like in the manufacturing and control, you find the historian, operational historians over there used very extensively. And then if you can share.
Yeah, go ahead and start the slides off. Let me move this forward here on this screen. Here we go. So operational historian. Why don't you start by telling us, what is a historian? You and I have been saying this word historian, and that might be a new term for our audience.
I've heard. The first time when I heard it, I thought it's like kind of a specific software or something, but it's basically it's a framework to organize and regularize the process of data collection and storage and let's say on the edge analysis. That in industries such as like manufacturing and in oil and gas, you generate a very high amount of data per time, and then for sure there's a margin of noise in this data, and then there is, let's say, a portion of this data that you really don't need, but the sensor is generating. So you need something in place that regulates the process of the acquisition of the data, the storage. Let's say if you are doing any compression, or if you are doing any kind of filtering, or let's say first site analysis or something. That's what all the historian does. Plus, nowadays, all the machine learning and artificial intelligence technologies, they started to let's say get into the historian to do some kind of on the edge analysis and storage. And then sometimes they refer to the historian as because it's close to the sensors, or to the point where you generate the data. So sometimes refer to it the real time database.
Yeah, no. So it's I think that's a really great explanation of what it is. It's a time series database, so it's meant for things like sensor data. It's meant for equipment sensors. It's used in a lot of industries like manufacturing, oil and gas, energy,
Exactly.
right? So
and it's all time series data. Since you are generating data over time, it's all time series data, but that doesn't mean that historian cannot handle the static data. For example, let's say the equipment information, or any metadata that you want to include with your with your data. You can go to the next slide.
Yeah.
So this is kind of a schematic, very kind of a high level overview. So at the level 0, you have the field level, where you have your equipment and devices, and then the second level you have the microcontrollers, which is basically the PLC, the programmable logical computers, and the DCS is the distribution control systems. That's where you, let's say, first get the data from the equipment, and then build your logic. And then the level 2, it's where level 2 and up is where your data storage will start, or basically is where your historian in action. And that's where you will kind of decide what to store, what to filter out, to build any logic, analysis logic. Yeah.
That's what we're getting into today, is the stuff that's downstream of the actual plant sensors, when we're bringing that data from the historian into Spotfire, and then actually building not just reporting, but analytics applications on top of that, where we can use that analytic data, non-transactional data. So
exactly. Yeah, exactly.
Cool.
Can you go next slide?
Yeah. There we go.
Yeah, so these are some of the historian functions, but they are not limited to these. It's basically data collection from the instrumentation, and then the instrument can be anything. Can be a pump, can be a compressor, can be a motor, and then the archiving, and then the aggregating of these data. For example, if you want to collect the averages, if you want to collect the maximum values only, all of these decisions are done at the let's say at level 2 on our chart and up. And they also they have this convention of calling each data stream. So for example, if you have a thermocouple that measures the temperature in a specific equipment, they call this time series a tag. So I think people who work with OSI PI, they're very familiar with the tag nomenclature, and it's also in Spotfire. And it's the nomenclature of tag. It's coming from the old times when they have these physical tags on the instrument, so they just kind of borrow that to use it on these measurements. You can also at the historian level, you can also And in OSI PI also, you can set up an alarming system. For example, if you want to get an alarm or like an event trigger action according to a parameter value, you can set that up at the historian level. And then the historian also does a very important task, which I consider is like maybe the main feature that I found useful when I use the OSI PI connector in Spotfire, which is like the interpolation. So it handles all these midpoint interpolations in case if you wanted to have like a specific number of points. And then also you can do a manual data entry. For example, if you have a flow threshold, and then this flow threshold changes over time according to a design criteria, and then you want the end user to be able to do that. Yes, that can be done also through the historian, and then it can be like it can be entered manually. Go to the next slide.
Yeah, so I think sorry, I was on mute there. For all intents and purposes, like when we talk about tag, we're talking about a certain reading that's coming off a sensor. So a tag might be a sensor itself, it might be part of a sensor, but it's a reading that's coming off a sensor. So that's when you're going to hear us talk about PI tags. And PI,
Exactly.
by the way, PI stands for plant information. So it's a plant information tag. Now, you might have, I'm not sure if you, I don't believe you have a slide on this, so hopefully I'm not jumping the gun on this, but when you're reading data from the field, you might have one sensor that's giving you a reading every minute, another sensor that's giving you a reading every 5 seconds, another sensor that's giving you a reading every second, another sensor that's giving you a reading every 10 minutes.
Yes.
They're all in different time intervals, right? And so when I want to query what happened on October 19th at 7:52 p.m. and 45 seconds, and when I want to query a specific point, I wouldn't have data for that point because something
Yes.
might be querying every minute, not every second. And so that's where that interpolation, I think, comes in, right? So the aggregation and interpolation is the time series database is smart enough to create a data point for us that's interpolated so that at any point in time that we are querying, we get some kind of value if there is something that was being read in the vicinity of that value.
Exactly, and then the Spotfire connector for OSI PI also, it has a very nice feature. It's called time weighted averaging. So, for example, if you're pulling averages or like if you're pulling interpolated data, for example, and then you have like let's say the range of your data, let's say is around 10, and then among these points, you have a point in one of the timestamp that is, let's say, 100. So when you do time averaging data, this point won't affect your like averaging that much, because you're kind of like weighting the data according to how long they lasted. So I mean, if this point lasted like only 1 second, it won't affect the rest of your averaging. That's one of the nice features also I really like in Spotfire connector. And it's I think it's set to time averaging by default, so you don't need to reconfigure.
Right.
Yeah.
Okay.
Let's see what this. Yeah. So this is I think kind of similar to what you talked about, Neil. The averaging and then the interpolation, and this is the exception and compression. So, for example, if you have let's say a thermocouple that measures your pump temperature. I mean, you have a pump, but then you want to measure the temperature using a thermocouple, and we know all these sensors, they come with they call it precision range or like accuracy range. So they tell you, okay, this thermocouple can measure the temperature plus minus, let's say, 0.5. So what you do here in OSI PI setup, you set up a rule that like wherever, like all the readings plus or minus the accuracy of this this sensor, ignore them. They just don't like log them to the system. In this case, you will be saving a lot of space, and you will be basically be performing some data compression. So if you can see here the data, like the picture with the dots only.
Oops. Sorry.
Yeah.
Yeah, there's a picture
Yeah,
of the
this
dots
is the
here.
dot. So this is, let's say, the raw reading. This is like what the sensor is giving you. And then the next one, you see, like you kept only a couple of points, and then basically within like what you kept only what is within the accuracy range. Uh, so
Right.
like if you have a couple of points within the same range, you don't need to keep them all. You just keep like the ones that really out of the range, and
You
then
keep enough to reconstruct the signal,
exactly.
but if there's a lot of like repetitive points, it
Yeah, and then you don't need to keep those because those are like noise, and then yeah, so you're good to go with keeping only these points. And then if you can see the picture on the top right, uh, so the two curves, they're like the let's say the data signature, the fidelity of the data is pretty much the same, but the difference here, you saved a lot of space, and you
Yeah, this top
also
one has a lot of points here. That's why it looks thicker. Might be hard to
exactly.
see, might be hard to see that on the screen, but there's point all along this top curve, and then down here it only has the points that are on these endpoints here of this triangular signal.
And that's pretty much how the also how the like the interpolation works. I mean, if you're um, if your if your points are, let's say, on these let's on this triangle, like where you have like these points, then you don't need to keep them all. You just need to keep, let's say, the 2 points that they kind of like define this path or this line. This has a very significant effect on enhancing the performance, and I personally experienced that when I dealt with lots of tags with lots of points. I mean, imagine if you're pulling, for example, 100 tags. Each tag is, let's say, 1 minute interval for example, a couple of months. That will
Right.
affect, yeah, the performance really significantly.
Yeah. So
And this
this
is also an explanation for what we were talking about. It's called the filtering noise. So if you see like this x deviate, so x dev is like the deviation from the signal. So this yellow band, it's, let's say, the expected range, the plus minus accuracy of a sensor. And then if you have, let's say, the reading point A, then all the subsequent points can be ignored because those are like all can be considered noise. But you still need to, for example, record F. But for example, in here, you save the, let's say, the space of 4 points. You don't need to, let's say, record B, C, D, E, because these are all like noise, and the system's like, and they are like expected within the range of, let's say, that sensor accuracy. And then these bands also they differ from sensor to sensor for sure. I mean, not all sensors they have like the same accuracy. But what is good is like you can, like in OSIsoft PI, you can configure these separately, like for each tag. And when we talk about
yeah,
like, I mean, if you have like a tag, because tag can be also something calculated, but we're talking about, let's say, raw data coming from a sensor.
right. We move on to the next slide. So this is showing just the overall architecture. I'll put this up here. So yeah, I'll let you go ahead and finish
Yeah.
up.
So this is let's say a simple setup for us PI architecture. So on the left side you have your equipment. You have, let's say, pump, motors, engines, or whatever. and then you have your sensors on them, and then like IoT sensors, and you have maybe they call it EDS, or like edge data storage, where you store the data on the edge, and then you have also a layer where you sometimes I think they call it the DCS, the distributed control system, where you relay the data to the OSI PI system, and then in there you have a place to store the data, which is the PI data archive, and then you have also a place to describe the data, which is the PI asset framework, and then the asset framework, it's basically it's just a way to classify your sensors, because if you've ever seen like a PI tag, I mean, the name most of the time the name of the tag doesn't tell you that much about the context, and then that's where the asset framework comes into the play to help you classify and then you quickly access, let's say, a specific subset of the data. And I think I have a slide that describes maybe part of this. No, the one that I think the last one. Yes. So, for example, you have these sensors. You have temperature, pressure, current, voltage, RPM, and then I've just color coded them according to, let's say, a very simple classification. So if you want to pull only the flow related measurements, then you can just like select that. Like say, for example, from the asset framework, you just select the flow, and then you will get the temperature and the pressure. If you want to pull only the motor related measurements, and then you can just like from the asset framework, you can just like select the class of motor, and then you will get, let's say, the current and voltage. And then these classifications, they can be like more than one classification. Maybe like a mechanical engineer at the pump station looks in a very different way from, let's say, a chemical engineer or a process engineer on these measurements. For example, maybe like the classification on the left now, it's like how a mechanical engineer sees the setup, but the classification on the right maybe like how an electrical engineer sees the setup. So you can have, let's say, multiple asset framework, and then having these can
a
help
different
you.
metadata model, right?
Exactly.
Depending on, so it could be the same sensors, but you're putting metadata on there for who's viewing it and how they want to view that data, and that's your asset framework. So
Yeah.
those two, this Pi data archive and the Pi AF is a Pi. That's a Pi asset framework. That's what we're going to be going over today with the TIBCO connection. So maybe we should just jump right into that. Do you want me to get started with showing a little bit on how you install the Pi connector?
Yes.
Okay.
Yeah.
So first off, I'm just going to show quickly how do you install the Pi connector? How do you get started with that? So let me zoom and make this a little more readable. So there is a community page. You can find this by just searching for Pi connector in Spotfire. So there's a community page by Dave Lee, and Dave Lee is the author of this connector. So credits to him for this connector. And he did work directly with OSI Pi and creating this OSI on creating this connector. So it's very robust. You can scroll down to the bottom and you'll see a zip file here, and you download that zip file, and that has the extension file. So then you'll need your administrator to install the Pi connector, and they can do that by going through the administration console, and they can go to deployments and packages, and they can add a package. And what they're going to want to do is then choose file, and they will choose a, let's see here. Let me grab the assets. Let's see, the extension. So I already have this downloaded, my OSI Pi. Then there's let me zoom in on this so you can see this a little bit better. So I got two folders, documentation for Spotfire server, and then for Spotfire server, you'll see different SPK files. And so these SPK files just have to be installed on the Spotfire server. You can select one. You can upload it. And once it uploads, you'll see this in the status here. Or sorry, you'll see it's actually already installed, so it might not show up here. But once you have it uploaded, you'll be able to then let me actually put it in the development area. Let's add it here. So I'm going to upload this. And so, yeah, you'll see. So I put this in a different deployment area just so you can see this on the screen. You'll see this add button here. You'll want to actually add all of those SPKs in, and then you want to hit validate area, and it'll say validation. It should say validation okay. And if validation's okay, you hit save area, and then that will actually save those extensions. And then once those extensions are installed, you can open it up right in the Spotfire Analyst. So Thier, let me go ahead and share your screen, and then you can show how this looks like in Spotfire.
Okay.
So when you go to the add data, can you show them how the
Yes.
Where the data connector is? So that will be in tools. You'll be able to see in tools. You'll be able to see create tag details, all of those options, create asset framework. So those are all the OSIsoft extension points that have now been installed into Spotfire. And then in the add data, there's also some more options.
And then you can also, I mean, sometimes I usually just right click, and then you can access them from here. This is another place, and then you can also. It depends on like how do you like get used to it, and then you can also access it from here. So it depends on how do you use it. Do we want to start with like showing how to use these connectors?
Yeah, let's go ahead and start showing how to use it from scratch.
And before I start, we have a question from Jose. He's saying, who developed this connector, PI and TIBCO, and then what are the licensing costs? Will this replace the Spotfire extension?
So this is a absolutely free extension. It's developed by OSIsoft and TIBCO together. Yeah, absolutely free. So no licensing costs at all. Just pull it right down from our community.
Okay. So let's start with the OSI PI data first. In order to connect, you have two ways you can use, and that goes for the OSI PI data and then for the asset framework also. You can use the graphical interface, or you can use the custom data functions to connect to that. So let's explore the graphical interface. So you can come here. It's like either from the plus sign, and then you click other, or you can go to tools, and then you choose the tag details of view, and let's choose that. You will get this dialog box, and then in here you will enter your parameters. So no, actually this is not the graphical interface, sorry. This is the graphical interface, the tag data. So this is your Pi server name, and then you can choose here like what is the how do you connect to the Pi server. Currently we're using the Windows integrated username and password, like our credentials, and then you can just click connect, simple as that. And once you click connect, these two tabs will activate. In here you have your tag selection, and then so assuming that for example, part of the tag that you're looking for, and let's say our tag has the name, the word power in it. And then also you can use wildcards here when you perform your search. So here we got all the tags that has the word power in them. And then if we want, let's say, a specific one, we can just like hold control and then also multi-select. and then you can click add to add them to your query. And in here, this is the data retrieval. And then how do you want to bring your data? So Neil talked about it at the beginning. Do you want to bring? I think I have a slide on that, but we can go through them one by one.
Here, I can
Actual
look at it real
value.
quick. This is your slide, right? On
Yes, good. Thank you. So actual values basically returns, the actual recorded values by the system. So if our system recorded only 4 points, we will get 4 points no matter how much we put here. I mean, even if we put a number here, we will get only the actual recorded values in the system. So that might not be the a good choice if you are looking to get, let's say, equally.
Yeah, so like those points may be at different time scales, so the
Exactly.
actual points may not be the right way. Like if you want to see what the measurements of all these sensors that Thea has, he's added to his graphical user interface. If he wants to see all of them at a certain point in time, he's going to need to interpolate on that, because the likelihood that the actual values all line up on a certain point in time is
Exactly. So if you want to, for example, pull 100 points of each sensor, this won't be a good choice. The second one, the interpolated values, this is basically, as we explained it earlier, it interpolates the values between the start and end time, and then it also uses the number of points that you give it to kind of like find these to divide the timeline between your start and end.
So that's going to fill in between the actual values, right?
Exactly.
Then the plot values, you say look at on a chart, but I think that's also the compressed values as well, right? So it doesn't overload with a lot of repeated values that could be noise. I think the plot values also,
Yeah,
I believe it might be the compressed values.
and there in TIBCO's manual, it was described that this is kind of like an enhanced version to make it suitable to be blotted. So yeah, I would assume it's like the noise will be suppressed. The snapshot, it's from its name. Basically, it's the current picture of the data.
Okay.
And then the rest of the measurements, these are all summaries. So if you want pull up averages,
Just
if you want to pull up
aggregations that can be pulled, right?
exactly, if you
I'm
want
just
to pull
gonna.
up minimum, maximum.
So yeah, I'm pull back up your screen. Just
Okay, yeah,
just keeping an eye on the time here. So
yeah. So and then so let's say we're pulling interpolated values, and then here the start and end time. These wildcards, they are like explained thoroughly in the OSIsoft TIBCO manual. You can get it from the same place. I think you downloaded the connector, and then these are like, it has like very very useful shortcuts. You can, I mean, if you're able to kind of understand it, it will be very helpful. So for example, the star basically in OSIPI is always, it means let's say the current time. It's like the current, like now. And then so in here we're trying to pull up, let's say the last 24 hours. So this is basically the
everything
start time. It's like now minus 24 hours, and then the end time is like now.
right.
And
And how many
so
points do you want to interpolate? You can choose like, okay, I just want 100 points, or I want 1,000 points in the past 24 hours, or 10,000 points in the past 24 hours. So
exactly,
you choose your granularity there, and then you can choose what time zone as well, right?
and I remember like we talked about the time weighted events also. So once everything is done, you should be getting a table, and then let's show the table of the data that we get from Pi. This is like a standard table that we. I mean, people who work with OSIPI, I think they're familiar with this. So it starts with like your Pi server, the tag name. And then, as we said, the tag names doesn't tell you that much. The retrieval mode. Well, like how are you pulling your data? And we're pulling interpolated values, the numeric value, and then you will have also a text value, because sometimes you're pulling, for example, pump statuses, whether it's on or off. So you will see these values here, and then you will see the numeric value empty. The timestamp that you pull the data, and the time zone, the status, and then in case if you have null data, or if there's like any sensor failure, you will see like the word bad here, and then also you will see it here also false, and then this is like the start and end time, and if there's like any comment, you will find them here. So this is basically your pi tag output table, and then it's a long format.
I wanted to point out on this is if you're using the Pi connector for Excel, you might be used to seeing it with each row is a timestamp and each column is a new sensor, is a new Pi tag. This actually comes in unpivoted, where all the sensors are on that second column tag name. So instead of it being across your data table, it's actually
a long format.
And I know for a lot of people, the first time they see this, they're like, oh, they expect to see it the same way they see in Excel. But in reality, your table should be unpivoted like this, because when you're creating a chart and you want to actually plot different tags, let's say on a line chart, you want to plot a different color for each tag, you want to use that column selector. So it might seem weird, but it's like this at first, but this is actually the better way to use it in Spotfire.
And then this is what, like, I got this moment of confusion the first time I was using Pi connector and Spotfire, because I got all the tags in like in one column, and basically I got the like a long version of the data. But then I realized that was like my first days with Spotfire. But then I realized this is basically what Spotfire likes. I mean, most of the visualizations,
unpivoted data sets, tall data sets.
Dealing like with long data will make it very easy to customize your visualization and to make everything kind of like a plug and play in Spotfire.
Right. So do we want to plot some of this data real quick, and then maybe we can move on to the asset framework? I'm just trying to keep an eye on the time here.
Okay. Let's add a visualization. For example, I don't know, let's add a line chart. And then, let's put our timestamp here. Let's average, or like, let's take an average, and then we can color it by the tag name.
So there's
tag name. Yeah.
There we go. So those are the different tags. So there we go. Like on the left, you see in one column all the tag names. And the reason you want that is so that on the right in this plot, you can just color it by all those tags, and it's easily separating your different signals.
And that's the benefit of dealing with unpivoted data. Will make it very easy to like visualize this without the need to like to do any further transformation.
Right.
So how much time we have?
Yeah, so if we want to move on to, I don't know what you had next, but maybe we want to show the asset framework.
Okay, so let's talk about the asset framework. Let's talk about the graphical interface of the asset framework. So as we explained earlier, the asset framework is just a way to describe your data. So this data set is wind turbine data, and then basically we have 3 levels. We have the farms, and in each farm we have a couple of wind turbines, and then for each turbine we have, let's say, a couple of measurements. So the asset framework graphical interface is pretty much similar to the OSI PI. We just connect to it, and then in here you have the possibility of connecting to different asset frameworks, and then here you can select what do you want to see. So for example, I want to see, for example, all the turbines in this wind farm. You can just select it and click this arrow, and you will you will get it here. So let's remove all of these so we can start. So for example, if we want to see all the wind turbines in this wind farm, so we have all these wind turbines, and then for each turbine, we just want to see, let's say, let's remove this. So we just want to see the wind speed. So so from here, you just select like the variables, and then from here you select your data structure, and then you also have your um, um, data retrieval. So if you want to pull, let's say, the interval values, if you want to pull uh, actual values or something, and then I don't think this has an effect because you're pulling just the data structure. Let's see what we get. So this is our table, and let's plot the table. Let's see what the table content.
So now we're just looking at the metadata, the asset framework metadata.
Yes. So we're just looking at one of the turbines, and then you still need to do some transformation on this, and then I think our this example is more complete if we want to go
Okay.
and.
Yeah.
So
Do you want to actually like pop back over to that graphical user interface on the asset framework? I felt like maybe we jumped over what were the different parts of that interface. What were
okay, let's see.
just a quick explanation of the hierarchy and.
Okay. So in here we said we connect to the asset framework,
Mhm.
and then in here we
So yeah, so that's where we have the actual hierarchy of the sensors that's built on the equipment, right?
yes, exactly. And then
And so this is not automatic. This is not automatically created. A human has to create this.
yes,
So
yeah,
it comes with your
you basically create a JSON or like an XML. They have like a template. You can and then they also have an application called AF Explorer. You can like simply build your asset framework over there and then upload it to the system, and then people who connect to the Pi server, they will be able to see this asset framework.
right. So what this allows is like you to not have to remember tag 005XYZ. It can allow you to say, I just want the temperature tag on my equipment, on my pump at facility ABC, right? So it's a more
Exactly.
human readable interface. And so you assign this structure, and this allows you to better access the tags, and it maintains that across like different views. If there's different people using this, they can use this asset framework. And then remember, there's like you can have a mechanical engineer that uses one asset framework and an electrical engineer that uses another asset framework. They could be looking at the same tags, but the way they're labeled might be differently depending on
Exactly.
how it was set up for them and what their domain expertise is.
And I think that's like one of the power features of the asset framework. It's kind of like enable multiple personas to interact with data in different ways without affecting each other. So like each one can connect to the asset framework using, let's say, his or her persona. So for example, if you have like a mechanical engineer, like electrical engineer, chemical engineer, they can like choose their asset framework and then connect that to the system using that.
Right. Okay, cool.
Yep.
So if you
Let's.
want, you can show her, the complete example of how you pulled it all together, and any tips you have for using, any tips you might have for using the Pi connector. I know you do some joins sometimes, and explaining what's happening in the hood.
Yeah. So this is basically the same asset framework that we looked at, and then I just like use the asset framework data and then visualize it. So in here we have 4 wind farms, and in each farm, once you click on it, you will have its turbines, and in each turbine, once you click on it, you will have the parameters that you're measuring. Now, if you click on any of the parameters, you will get like a chart. And so basically what we are doing here, when we click, we are building the query to send it to OSIPI. So we're using the asset framework to build the query. And basically, because when you click on this and this and this, you're just like filtering down using the asset framework, and then use, let's say, that resulted filter tag, and then send it to OSIPI. And then I will explain it in a minute, and then how does this work. And then you can also like hold control and then like select like multiple parameters. So basically, let me show the asset
Yeah,
framework.
take a look at how the data is working.
Yeah. So this is how the asset framework data is organized. So you have like when you click on for example on an element, for this is like the turbine name, and then this is like a level up, and then this is like a more level up. So you have, this is like the parent element, and then we are using the tag of this. So this is the path, and then let me so this is the variable, let's say the variable name. What are we using this, for example, this longitude, latitude, or anything else. And there should be, let's see, metadata. Yeah. So this is like the final cleaned one. So when you keep clicking on this like farm turbine, and then you click one of the variables, basically you are filtering down to the pi tag level, and then that's what will be fed to your OSI pi data functions. So basically we're using the asset framework to build our query visually, and then we pull the data back to OSI pi. So let's take a look at the OSI pi, and this is how you build your OSI pi query using the data function, not the graphical interface. So if you look at the parameters here, so server, we have, it's the same. I mean, username, password, you just leave them. What's the most important thing here? It's the tag name, and then the tag name, basically we're just feeding that from this table, and that's one of the
So this
one of the
data
great.
function, this is created automatically by the Pi connector when you're connecting, right? So it's connecting to
Yes.
data through a data function, and what
Yeah.
showing is like how it actually set that up.
Yeah, and then this is like one of the great features in the connector, because you have a lot of control here. You can even use custom expressions, Spotfire custom expression, to build your query. But basically, we were just using here, we're using this table, and then we're using the filter that we are building visually. So we're using the marked rows. So whenever like you mark, then the marked tag will be fed to the tag to get the query out.
So rather than pulling all the data, you can actually pull a list of tags, and then when
Exactly.
you select that tag, it'll run a data function, and it'll pull the data for that
Yeah,
tag. So
exactly.
select a tag. A tag is a sensor. Select a sensor, and
Hmm.
pull the data as you select different data. As you select different tags, it'll pull data as
Exactly.
you select different tags.
And in this case, you don't need to memorize anything. I mean, basically, you just need to come here and just follow the logic. You select this, for example, this turbine, and what do you want to see? And these are all included with the description of the in the asset framework. So basically you don't need to remember any.
So rather than going and pulling a bunch of data, you can use the asset framework metadata, get your list of tags, and then just pull your data right from the asset framework. And that makes it easier to build a more complete picture of what you have, because you're working from that metadata at the plant level. And
Yeah.
does this work on the web player as well? We got a question again from Jose.
Yes, it does. It does work on the web player, and then I've created previously tools for like field engineers that can just like quickly come if they don't have, let's say, the tag name. They can, for example, just come and then quickly click, and then they get the tag names for a specific parameter.
Great.
Yeah.
Okay.
Yeah, and so this has like a lot of possibilities. It can also help you to quickly trend any of the variables, or for example, if you want to compare the active power for let's say the first four turbines of a specific station, or like if you want to let's say compare that for different stations, you can also do that. So
there
I mean,
yeah,
open horizon, you can use your imagination and then come up with a lot of cool things to do.
Yeah, there you go. That's a good view. Any other tips that you have for our audience when working with Pi data?
I'm sorry?
Any other tips that you have for our audience when working with Pi data?
So sometimes you have, for example, you have a specific data structure in mind, but you don't want to let's say go, or maybe you won't be able to go and then build it as an asset framework in the system, or like maybe you don't need to do that, to go that route. What I used to do, basically, I just like open an Excel and then list all my tags, and then list, let's say, all the list all the sorry list the tags and all the classifications I need, and then I just like join that to my raw data table, and then
so you get together all your tags first in a spreadsheet.
Yes, you get your tag.
Join that spreadsheet.
And that's what lots of use cases previously, when I get like from the oil field people, for example, they get me like list of tags, and then there's like a description or a classification next to each tag. So I use this, and then I join it back after I query my data.
Why don't you show us that join real quick in your data canvas?
Yes, sure. So this is the tag detail view, and actually we performed a join here. So basically, we joined the asset framework, and then we use that to achieve this display, and then your join will be built on the pi tag on both sides, and then you can bring whatever columns you need. The columns I brought are these columns. So, for example, I want the region, the farm.
So now you're getting the asset framework names. So the asset framework's got the clean names and the clean metadata, and then the Pi tag table has all the censored, all the measurements. So what you're doing is joining it together, so you have some clean some clean names from the asset frameworks combined with some nice detailed sensor data all in one.
Yeah, exactly. Basically, you're giving, let's say, a human readable definition for your Pi tags, so people can use it to further classify, visualize the tags easily. And that comes like very handy and very helpful when you are dealing with, let's say, lots of Pi tags, and let's say lots of classifications and levels in your data structure.
Right.
Yep.
Cool. Well, Athir, thank you for your session today. I mean, I reiterate that I think the OSIsoft PI system is a really big differentiator that Spotfire has, in that it allows you connection to these data historians. The OSIsoft PI system is very popular, very widely used. So we decided to do this topic for this session because we know we have a lot of users out there that are using Pi data, and they may not be aware that they can use that with Spotfire, and they can actually build. I know we showed that it connected to a data function, but you can actually build data functions on top of that data as well, and do deeper analysis, do machine learning, do advanced statistics, or even just using physics-based equations, whatever you want to use logic and use data functions as well. So there's a lot that you can do with that, and I think it's important to get that information out there. So thanks again for showing that to us.
Thanks for having me.
Yeah, definitely.
And
Appreciate
just to mention, the manual that comes with the connector where you download it from, it has a lot of useful information and how to use the custom expressions. So if anyone wants like more information or to like deep dive, I would recommend reading that manual.
Right. Yeah. And so that community page, we'll put that in the video description on the YouTube link. And, there's I see Jose's got another question about the driver. Remember, we installed those SPKs in the beginning of this session. That's going to be everything you need. So there's no separate driver. There's going to be a community link we'll put in the video description that gives you the SPK files, have your admin deploy those and deployments and packages. And then all of a sudden, wow, boom, you're going to have the Pi connector in your Spotfire analyst interface. All right. Thanks again, Athir. Appreciate your time. And we will catch everyone next month for Database Write Back. And Athir, you'll be joining us again for that as well, right?
Stay tuned.
All right. Take care.
Bye-bye.